Alright, let's move on to these questions. A spherical fishbowl of radius radius 30 cm, okay, contains water of refractive index 1.33. A small goldfish is 10 cm from the front wall of the bowl. Okay, where will the goldfish appear to be for an observer at the front wall of the bowl? The effect of the thin glass wall is assumed to be negligible. Okay, the thin wall, it means we just consider this as a big sphere. The wall of the, the fish bowl, and because we know that this is like an aquarium, aquarium with water inside. So there is glass, there is water. We assume the glass is like, there's no glass. We assume like very thin. It's just a very thin glass wall. We can just neglect the glass lah. Because it got water, it got glass, got different refractive index, isn't it? Different refractive index. But we just neglect the thin glass wall. We just assume only have water. We have water. Yeah. The light just pass through from water to the air. Okay, water to the air. No need to consider about water to glass to air. No need. Yeah. Just neglect the glass. The glass is only very thin. Okay. Do you see there is a difference between this question and the previous questions? This time, this is an aquarium, and the fish must, of course, inside the aquarium, inside the fish bowl. The fish won't be outside the object. Yeah, this is what we call the. This is the object. Understand or not? This is the object. This object, the fish, must of course inside the water. Must of course inside the water. How can be the fish is outside the water? Okay, so this time the fish is inside the water, and the observer, of course, is outside the aquarium observing the fish, isn't it? The eyes, the person is outside the aquarium looking at the fish. How will the goldfish appear to be the observer outside of the aquarium? Cannot be observer inside the aquarium and the fish outside, isn't it? Use your logic lah, use your common sense. And so you see, there is a difference between these questions and the previous question. This question is the object is inside the glass. Oh no, inside the water. Okay, inside the water. So the incident ray, of course, is from the object. Yeah, incident ray come out from the object, and then the ray from water go to air. You see or not? Refraction. Again, this I want to emphasize that this is about refraction, not the reflection, not reflection. Reflection, not reflection. If reflection is incident ray comes and then reflected away, that is only for mirror, and that is only for mirror. But this is a refraction. Refraction means incident ray comes and then penetrate, the light penetrate and then go outside. Refracted ray. Okay, so not this one, not the below one. So we can rub that off, yeah, because it's not related. Now, so this is the difference between this question and the previous question. This question is object is inside the water, and the light goes from water to air. Previous question is the sumo wrestler is outside, so the incident ray come from the air, go into the glass. See or not? This one is from outside, go to inside. From outside of the glass, go to inside of the glass. This question is from inside the water, go to, the light comes from inside the water, go to outside of the water. Right? Yeah, is how it happens lah. So my method is, you must always draw the incident ray and reflected ray first. This is the priority. Understand or not? My first step is draw IR ray first. IR ray first. Then only second step, only we compare to get the positive or negative for all these object distance, image distance, and radius. Understand or not? My first step is always draw the IR ray first. So I already draw incident ray and refracted ray. I already draw already. and this one is object is inside. You must identify is the object inside the medium or outside the medium, inside the material or outside the material. Like the sumo wrestler, this one is the sumo is outside the material, not inside the material. The sumo is outside. This one, the goldfish is inside the material, not outside. So the incident ray and the refracted ray also become opposite. This one is the incident ray is from outside go to inside, and then this one is incident ray is from inside go to outside. All this is very big changes. All these affect the positive and negative sign. You must know the light come from where to where. Okay, this is the first step. Now, once I already identify the situation, easy already. You can solve this question already. The incident ray come from the object, and light goes out, become refracted ray, and go to the observer eyes. The light. Why the person can see the goldfish? Why the person can see the goldfish? Because the light come from object, go to the eyes. That's why the light enters the eyes, and that's why the person can see the object. Okay. Now let us continue. Here it gives us a spherical fishbowl. It's a sphere. That's why it's a sphere. Fishbowl of radius. This is the radius lah. I already give us the radius. And then give us the water refractive index. This is the refractive index for water. And then a small goldfish is 10 cm. Is this a goldfish? This is the puffin fish. Never mind. I don't have the goldfish here. So the goldfish is 10 cm from the front wall of the bowl. 10 cm. This is the goldfish is the object lah. Goldfish is the object. This is the object. That's why I label as O. And this must be the object distance. And seems that this object distance is smaller than the radius. 10 cm, radius is 30 cm. That means it is nearer to the surface compared to the radius. Radius is over here lah. Okay. So where will the goldfish appear to the observer? So we want to find where will the goldfish appear. What is mean by goldfish appear? Goldfish appear means what the observer see. What do the observer see? What do the observer see? You see the image. Observer always see the image. So goldfish appear. This one means the image. Understand not? This one means the image. Where will the goldfish appear? That means where is the image distance? This question is asking about V. This question is asking about where is the V, image distance. Where is the image appear for the observer to see? So this first question is asking about V. We need to find V. Understand or not? Okay. Now let us continue doing the questions. So the radius is either, you see, I put positive or negative. We don't know yet is we put positive or negative. We don't know yet. How do we know positive or negative are? Compare with refracted ray. If same side with refracted ray, positive. If opposite side to refracted ray, the radius, that is negative. Remember that. This one is what we learned before. To compare positive and negative, object distance always compare with incident ray. Object we compare with incident ray. If same side positive, opposite side negative. But for the rest, like image distance and radius, the rest only the object compare with incident ray. The rest like image distance and radius compare with refracted ray. If same side with refracted ray positive, opposite side to the refracted ray is negative for the radius. So look at this one. Okay, first of all, we start with object distance. Okay, this object, is it same side as incident ray? Let's draw out. Is it same side as refracted ray? This is the object. U. Is it same side with U compare with who? U compared with incident ray. Only the U compared with incident. The rest compared with refracted ray. So U is same side with incident ray. That's why it is positive. So we put as positive U. This one is U positive. Then now how about the we want to find V. We already got the U. Now we want to find V. R. How about the R? R is provided. This R. So R, is it positive or negative? Look at the sphere. This sphere is curved to the right. You see, it curved to the right. So where do you think is the radius for this surface? Where do you think is the radius for this surface? Of course, it's to the right. The radius is of course to the right. Let's draw out. Our radius of this surface is this is the this is the radius. Radius. Let's draw the radius. This radius is equal to the radius. This radius of this sphere. This radius is positive or negative? Radius compared with who? Radius compared with refracted ray. If same side positive, opposite to refracted ray is negative. So my radius is opposite to refracted ray. So do you see that? Our first step must always draw the IR ray first, the incident ray and refracted ray first. You must first draw this, then only you can compare to get the R is positive, the radius is positive or negative. If you don't draw the incident ray and refracted ray, you have nothing to compare. Okay? So, my radius here is opposite to refracted ray. Opposite. So, this is the virtual radius. This radius is opposite to refracted ray. So, it's negative. My radius here is negative. Or we can say negative. Negative 0.3. Understand or not? It's negative, opposite. Some books says because this is this surface for the fish is considered to be concave surface. Is considered to be concave surface for the fish. Concave surface always has R negative for this fish lah. But I don't like to use this method. You must memorize concave negative, convex positive. Very hard to imagine. I like to draw. I like to draw the incident ray and refracted ray only. Then I can easily compare to get positive or negative. Understand or not? You see like this one. This radius is of course to the right. So but the refracted ray is at the left. So they are opposite. The radius is opposite to refracted ray. That's why this radius is negative. Easy. Just draw only. No need to remember concave surface or convex surface. Okay. Now, I already got the U and V, U and R. Now, I want to know the refractive index N1 and N2. Remember, N1 and N2, what does it mean? N1 means the light comes from N1 go to N2. The light travel from N1 to N2. That means, where is my N1? N1 is at the incident ray. N1 is at the incident ray. N2 is at the refracted ray. The light goes from N1 to N2. So N1 is the water. N1 is the water, which is what? Which is N1 is the water, which is 1.33. Goes to the air. Air is equal to 1. Understand or not? From N1 to N2. N1 to N2. So from water go to air. From 1.33 go to 1. Last time the sumo wrestler is from air to the glass. From air to the glass, from 1 to 1.5. From air to the glass. From air to the glass. But this time, last time is from air to the glass. This time is from the water go to the air. That's the difference. Understand or not? Okay, we already got everything. So now just calculate. Just substitute and calculate. So N1 is the water. N1 is the water. U is positive. U is a positive. U is put as positive. What's the value? U is 0.1. 0.1, just put as 0.1. Okay, again 0.1 plus N2 is 1. Yeah, is from water go to the air. And then V is what we want to find. Equal to N2 minus N1 is air minus the water. Air minus the water. Yeah, because it's going from water to air. My R is negative. Negative. What is it? The R 0.3. Where's my radius? Okay, let's calculate. Let's calculate the V. My V I get, after I calculate, I get my V is negative. I got is negative value 0.082. Yeah, 0.082 meter. Okay, what does it mean? What does it mean by this negative sign? This negative sign means it is a virtual image. It is a negative V means it's a virtual image. If negative V means if V we compare with who? V we compare with refracted ray. Image distance compare with refracted ray. Now I get V we compare with refracted ray. Now we get V negative. V negative means what? V negative means if V is negative means it's opposite side from the refracted ray. It form opposite from the refracted ray. So we can say form opposite of the refracted ray. Where is the refracted ray now? The refracted ray is at the air. Refracted ray is over in the air. So where is the image form? Can it form same side as the refracted ray? No. So where is the object appear to the person, the observer? Do you see the image of this? Do you see the image of this? Do you see the image of this goldfish in front of the aquarium, in front of the fishbowl? Is it form? Is the image form same side as the refracted ray? No. This virtual image it form opposite side of refracted ray. That means the image a person see is still inside the water. Understand or not? Opposite to refracted ray. That means he see inside. The image he see is inside. Is virtual. And then another thing is see the goldfish is upright or inverted. Is it upright or inverted? You see the dead goldfish there? Inverted for goldfish? You see, like always you see in the aquarium. Do you see the old fish died? Inverted? No, you still see the image is upright, isn't it? It's a virtual upright image. When virtual, remember the revu. Remember the revu? Now it's virtual upright. So virtual is you still see the virtual image. Means it's still upright image. It's still upright image. Understand or not? Upright. That means now he see the fish is still upright, but virtual. And this one of course is smaller. You see a smaller fish. You see the fish like is still upright. Still upright over here. Upright over here. This is the image form. But upright lah. Yeah. See the goldfish inside there. I see the goldfish inside there. Yeah. Still see the V is negative. This one you get the V. The V is let's write off this one. Okay. So he see the image V is negative. This V is negative. Why V is negative? Because it is opposite to refracted ray. The person still see the fish inside the water. V is negative, opposite to refracted ray, and it's still upright. Virtual is upright. Yeah, you still see the fish as upright, not inverted like dead fish. Okay. All right. Now, okay, that's good. So that is a way lah. Yeah, understand? Now let's move on to the next question. The fishbowl is placed near the window. Okay, where? Wait. Near the window where it received the evening sunlight. Is there any risk that the eyes of the goldfish may be damaged because the sunlight may focus sharply on them? Now, who becomes the observer? Is still the human or is it the goldfish? Now he's saying about what is the object. Now, what is the object? The object is the fishbowl received the evening sunlight. So the object is the evening sunlight. This is the object now. Yeah, this is the object now. The evening sunlight outside the goldfish, outside the aquarium, outside the fishbowl. The sunlight is the object now. Now, who is the observer? Who is the observer? The goldfish, the eyes of the goldfish. So now the goldfish is the observer. That means this goldfish want to see the object sunlight. Object sunlight. So this is the one lah. I see it here. Sunlight is the object. So goldfish become the observer. So you must draw the incident ray and refracted ray. So the light come from where? Come from the object. Come from the. This is the object. Understand or not? This is the object. So light must come from object. Then light come from object. So the light reflected or refracted. Is it this is not a mirror. Not a mirror. So this is just a glass. A glass means the light can enter. So incident ray and refracted ray. Always draw incident ray and refracted ray first. Then only you can compare to get positive or negative. So this time this time is opposite to the first question. Part A. Last time incident ray come from inside the water go to the air. This time the light come from the air to the water. Because of the object. Last time the object is inside the water. So the incident ray the light come from inside the water go to the air. This time the object is outside the water. Outside the water, so the light come from outside the water go to into the water. So that's the difference. And also the thing is now N1 is the air already. Understand or not? N1 is the air because come from the sunlight. Yeah, the light come from sunlight go into the water. So from the air go to water. Water is N2 already. Refracted ray is N2. Incident ray is N1 and incident ray is N1, refracted ray is N2. So N2 is 1.33 already. Okay, we got already N1 and N2. This is the object. Now, where is the object? Where do you think is what is the object distance? Where is the we also want to know where is the image form for this question. So where is the object? They give the object distance. How far is the sunlight from the fishbowl, from the fish? Where is the sun? Is it nearby? Is the sun nearby our earth? No, if nearby our earth already got burned already. This fish, all this water evaporated and this fish died already. This sunlight, of course, from the far away. If from far away means what? Means is the object is at infinity distance. The object distance is at infinity. Is it positive or negative? Is it positive or negative? Object distance. Object distance is of course positive. Positive because object compared with incident ray, same side, positive. Same side is positive. So it is at very, very far away. So we just put as infinity. Just put as infinity because come from very far away. Now, how about the radius? How about the radius of this surface? The radius of this surface, now we put as what? The radius of this surface is to the left or to the right? Of course to the right, because just follow the shape. The shape is the curve to the right. The radius of course to the right. So radius is to the right. This radius is positive or negative? This radius of course is positive. It's positive because same side as refracted ray. Same side as refracted ray, positive. Understand or not? This radius is positive. This radius is positive because same side as refracted ray. Remember, our radius compare with refracted ray. If same side positive, opposite side negative. This time my radius same side as refracted ray. So that's why my radius is positive. Positive what? Positive 0.3. Do you see a difference between the part A and part B? My part A, my radius is negative. My part B, my radius is positive. Why like that? Part A is still the same surface. You see, still the same surface, but the same surface can be negative, can be positive. It's all depend on where is the refracted ray. That's why I need to draw the incident ray and refracted ray first. You must always draw the incident ray and refracted ray first. Where is the incident ray and the refracted ray depend on where is the object. Last time my object is the fish. This time my object is the sunlight. So it's inverted already. Now last time the incident ray from water go to the air. This time is the incident ray from air go to the water. So that's why the refracted ray at the different side. And that also makes the radius from negative become positive. Then last time my radius is negative because it is opposite to refracted ray. This time my radius is positive because it is same side as refracted ray. Understand or not? So I already got everything. Now I just wait for me to solve the questions. Just substitute and get the answer. Substitute and get the answer. So my n1 is 1. My object distance is very far away. Very far away is infinity. My sun, the sunlight is at very, very far away as infinity distance. And then n2 is 1.33. And then v, we want to find the v. And then so it's n2 minus n1, 1.33 minus 1. You see, last time is 1 minus 1.33. This time is 1.33 minus 1. So different, huh? My r is positive 0.3. Last time negative 0.3. Now it's positive 0.3. All because the object is different position. Yeah. This one is positive 0.3. So just put positive 0.3. Now calculate the v. What v do we get? 1 divided by infinity. Of course, you get 0 over here, and then get the v is positive. I got my v as positive 1.21 meter. Is from 1.21 meter. So what image do you get? Is it a real or virtual image? This v is positive. V positive means what? V positive, it means it's a real image. It forms a real image. So image compare with who? Image compare with refracted ray. So now I get v is positive. V positive means same side as refracted ray. V must be same side as refracted ray because v is positive. Same side as refracted ray. So where's my refracted ray now? My refracted ray is inside the water, isn't it? So my v is measured from where? Same side. My v must be same side as refracted ray. That means from this surface, I measure v. My v is positive. My v is positive. My v is positive because same side as refracted ray. Yeah. So from here I measure. From here I measure same side as refracted ray. I measure 1.21 meter. My v is 1.21 meter. My v is positive, same side as refracted ray. So my image is formed to the right hand side. So where do you think is the image formed? This light will focus at what point? Will focus at 1.21 meter away from this surface to the right hand side, same side as refracted ray. So 1.21 meter is how long? Is it the light focused inside the water? How big is the sphere? Need to look at the radius. The radius is only 0.3 meter. That means the radius, funny thing is the radius I mean the diameter of the whole fishbowl is the diameter of the whole fishbowl is 2 radius. 2 radius is 0.6 meter. Oh, the diameter of the fishbowl is only 0.6 meter. That means this image is 1.21 meter, larger than the diameter of the fishbowl. So that means the sunlight won't focus inside the fishbowl. The sunlight will focus somewhere. The sunlight will focus somewhere outside the fishbowl. The sunlight will focus somewhere outside the fishbowl, around here. Maybe the sunlight will focus over here. The sunlight, it form an image over here. Form a real image over here. Form a real image over here. Means if we put it form a real image. It form a real image. Understand or not? It form a real image. That means if you put a screen over there, you put a screen over there, you can see the sun on. You can see the sun on the screen. You can see the sun on this screen. It form on the screen 1.21 meter away from this surface. 1.21 meter is already bigger than the diameter of the fishbowl. So the image is formed. What I say? The real image is a real image of sun is formed outside the fish bowl. Outside the fish bowl. So is the fish safe? The eyes of the goldfish will be damaged or not? Will the sunlight focus on the fish inside the water? No. The real image of the sun is from outside the fish bowl, so it will not focus on the eyes of the fish. So the fish can live inside the water. Understand that? Can live inside the water. The sun you can catch on the screen outside the fish bowl. Outside the fish bowl. So we can say this V is bigger than the diameter, which is 0.6 meter. So the fish is safe. Why is it safe? Because the real image of sun is formed outside the fish bowl. Okay, it's formed outside the fish bowl, so it's safe. No harm. Okay, no harm to the fish bowl. Image of the sun. The real image of the sun is formed outside the fish bowl. That means we can imagine like this. This is the fish bowl. This is the fish bowl. Okay. So this is the fish bowl. Yeah, the fish bowl. Okay. So the sun. Yeah, this is the object. Okay, this is the object. Okay. The sunlight. Sunlight comes from infinity distance away. You will focus outside. You'll focus outside the fishbowl. So focus outside the fishbowl. That means put a screen over here. Let's say a paper. You can see the sun over there. Okay. So inside the water is safe. The fish can swim happily in the water. Okay, I can swim happily in the water. That's the fish. So focus outside the fish bowl. Okay, see you for the next videos. Yeah, that's all for these questions. Okay, hope you enjoy, and we move on to the next question. Okay, see you. Thank you. Bye.